So in this video, I'll show you how to create or sketch a phase plot using the isocline method. So you saw the table, and now we will draw the equations from those tables. So it says there x1 equals plus or minus 1. Okay, so that's a line. So first we draw an axis. Say ito, this is the x1 axis. x1, and let's put this as the middle, and this is 0, and then we'll have 1 here, plus 1, and negative 1 here. And then we'll have this as our x2 axis, x2 there, and this is 0, and this is, let's say this is at plus 1, this is at negative 1. 5, negative 1. Right. So suppose this is our state space, x1 versus x2. When we have the equation x1 equals plus or minus 1, and it's an equation of a line corresponding to a slope m equals 0. So we draw x equals plus 1, and this is x equals plus 1. x1 equals plus 1. So this is x1. There's no dependence on x2, so x1. And then this is x1 equals minus 1. Okay? There. And then the corresponding slope for this isocline is 0. So all around this, we put, ang itsura ng line na 0 ang slope is a flat line, a horizontal line. So everywhere here, we put representative horizontal lines like this. Okay? All the way up. Okay. Then we have, if you look at the other extreme, at a slope equal to infinity, the isocline equation is x2 equals 0. So the line x2 equals 0 is just this line here, x2. Okay? And the slope infinity, or rather lines that look like they have infinite slopes, are vertical lines. So all along this isocline, we draw small vertical lines like this. There. Next, we can use the isocline equation for the slope m equals plus or minus 1. The isocline equation there is x2 equals plus or minus quantity 1 minus x1 squared. And so that's an equation of a parabola. And let's take the positive slope first, plus 1. No? So it corresponds to the isocline equation x2 equals 1 minus x1 squared. Okay? So that means when so this is x2 equals 1 minus x1 squared. So when this is equal to 0, x2 equals 1. Okay, so when x1 equals 0, x2 equals 1, so there's a point here. So this would be the apex of your parabola. Now, when x1 equals 1, then this is 1 minus 1 squared, and this is 0. So that means when x1 is equal to 1, this is the point x2. Okay, and so also when x1 equals negative 1. So you can imagine that the parabola opens this like this, downward, like this, passing through the 0 like this. And for the case when the slope is equal to minus 1, so in this case, where the slope equals minus 1, the equation for the isocline is minus 1 minus x1 squared, or it will just be the same parabola except that now it's opening up. So you can expect that because of symmetry, this would look like this. Okay, just like this, and this, more or less. For the case when the slope is equal to plus 1, this is the equation we follow, and this is the curve. A slope equal to 1 means that the representative lines here should be 45 degrees positive. So all around this parabola, you put diagonal lines 45 degrees. Okay, 45 degrees all the way here, even here, okay, 45 degrees. Okay, on the other hand, if this is the case when m equals -1, then it's also a diagonal line, but it's diagonal in this direction. Okay, just like this. So keep drawing these diagonal lines all the way here. So keep drawing these diagonal lines all the way there on the isocline. Of course, you can proceed to draw the other isocline equations and draw the representative slopes on them, but this should be enough. So given this, now you can start drawing the phase flows. Okay, so for example, it seems like there's a phase flow here. It would, following these isoclines, I would expect a phase flow like this around here, right? Take a look at the inclinations along these lines. Okay, all right. While these, it seems like I go from here, and then I go here, and then I go away. Okay, and in fact, you could expect that actually. So if you had more representative slopes here, you would see that they would approach this, but as you go closer and closer to this, you could have the case where you go this way. Okay, and in fact, for those of you who have done this assignment, you would have seen this kind of behavior, right? There. Wasn't this our exercise last time? There.